Let's solve this problem. If alpha plus beta plus gamma equals to 2 pi, then the system of equations, there are three equations given in three unknowns, which are the linear equations. It's a homogeneous, so we have to find whether it has an infinitely many solutions, exactly two solutions, no solutions, or a unique solution. So now, as it is a three equations in three unknowns, so we can construct a matrix. Say a matrix A is equals to 1 cos gamma, cos beta, cos gamma, 1 cos alpha, cos beta, cos alpha, and 1. So we know that if determinant of A is not equals to 0, then it has a unique solution. We know that if determinant of A is equals to 0, then it has infinitely many solutions. No solution option is definitely not possible because it's a homogeneous system. So 0 comma 0 comma 0, it has a solution. So now as this question is asked for alpha plus beta plus gamma equals to 2 pi, it is for the any partition of 2 pi. So we can take some nice values of alpha, beta and gamma and check whether the value of this A, whether the value of the determinant of A is 0 or non-zero. As it is a generalized question, the question is for any partition. So for example, we can take alpha equals to pi by 2, beta equals to pi by 2, and gamma equals to pi. So here we have alpha plus beta plus gamma equals to 2 pi. So now let's calculate determinant of A. So determinant of A is equals to 1, then it's a cos of gamma. So it's a cos of pi, which is minus 1, then cos of beta, which is cos of 90, 0, then cos of gamma, which is again minus 1, then it's a 1, then cos of alpha, it's a cos 90, 0, then again cos beta 0, cos alpha 0, and then it's a 1. And the value of this determinant is equals to, it's a 1 times, this is equals to 1 time, it's a 1 minus 0 minus, it's a plus 1 bracket, it's a minus 1, and then it's a plus 0. So the value of this determinant is 0. So which says that it has an infinitely many solution. So option A is correct. So if you want, you can write a detailed solution of this, but as I said, this idea will be useful to get the answers quickly. So now let's write a detailed solution. Basically, I mean to say, not by not taking the particular values of alpha, beta and gamma. So now we are going to consider the matrix A and we are going to calculate the determinant of that. So now let's consider determinant of A is equals to 1 cos gamma, cos beta, then cos gamma, 1 cos alpha, then cos beta, cos alpha, 1. Okay. So now we know that alpha plus beta plus gamma equals to 2 pi. So we can eliminate one parameter by using this equation. Okay, so we can get the value of gamma, which is a 2 pi minus alpha plus beta. And let's substitute this relation here. So then we are going to have only two parameters, alpha and beta. So we have 1 cos of, then it becomes 360 minus theta. So cos of 360 minus theta is cos theta. So it's a cos of alpha plus beta. Then it's a cos beta. Then here it's a cos of, again it's an alpha plus beta. Then 1. Then it's a cos alpha. Then cos of beta, cos alpha, 1. So now at the place of cos of alpha plus beta, we are going to use the formula of cos of a plus b, which is cos a cos b minus sin a sin b. So now this is equals to determinant of, it's a 1 cos alpha cos beta minus sin alpha sine beta, then cos beta, then again here we are going to have cos alpha cos beta minus sine alpha sine beta, then 1 cos of alpha, then cos beta cos alpha 1. Okay, so now let's simplify this. Now let's calculate the determinant. So now this is equals to 1 times bracket 1 minus cos square alpha 1 minus cos square alpha minus bracket cos alpha cos beta minus sin alpha sin beta, then multiplied by cos alpha cos beta minus sin alpha sin beta minus cos alpha cos beta. Okay, so plus cos alpha beta plus cos alpha cos beta and minus cos alpha cos beta gets cancelled, then plus cos beta, then bracket so then plus cos beta, then it's a cos square alpha cos beta minus sin alpha sin beta cos alpha. Okay, so then it's a minus cos beta. So now we just have to simplify this. So now this is equals to, it's a 1 minus cos square alpha plus sin alpha sin beta cos alpha cos beta minus sin square alpha sin square beta sin square beta then plus cos square alpha plus cos square alpha cos square beta minus sin alpha sin beta cos alpha cos beta minus cos beta then minus cos square beta. So now we can see that sin alpha cos alpha sin beta cos alpha cos beta gets cancelled. Okay, so now what we are left with, then we have 1 minus cos square alpha, it's a sin square alpha minus sin square alpha sin square beta, then plus, then we can take cos square beta common or we can take minus cos square beta common, we can take minus cos square beta common, so we are left with 1 minus cos square alpha 1 minus cos square alpha. So now further simplification, I think only the identity formulas are getting used, going to get used now. Okay, so now this is equals to, it's a sin square alpha is common and we are left with 1 minus sin square beta, which is cos square beta minus it's a cos square beta, it's a 1 minus cos square alpha, it's a sin square alpha, and the value of this determinant is 0. So as the value of determinant of A is 0, it says that the system of linear equations has infinitely many solutions. So option A is correct. So that's a very important point, that if you understand the question well, you will be able to apply such tactics to get the answers quickly.